Okay, so let's get this show on the road. I have a new assignment that is available. So if you didn't get a paper copy, I have an extra here for you. And hopefully everyone else got one. Assignment 3, Peg Solitaire. Does that sound familiar? If not, I have some up front. Let's look at it in Word. Oops, there we go. Word, yes indeed. So this is going to be your recursive backtracking assignment. Oh, I clicked on the wrong one. I did that earlier too. It's beguiling. Stars and Stripes is a good assignment too. I've made some changes from last quarter, so hopefully it's less horrifying. But no promises. All right. But now this assignment is also difficult. So the first thing I want you to know is that you really should read it, okay? And hopefully I can zoom it to a place where you can actually read it. Yeah, anyway, please do read it before starting it. So even if you're still working on assignment 2, maybe take this to bed. It's got little pictures on it and stuff, so maybe it's interesting to look at. Attracts the eye. So let's start off with the Peg Solitaire game demonstrated in class. Wait, do we have a Peg Solitaire game? Well, let me just go into Chrome here. Now I have a link in the assignment to this very thing that I'm about to search for, but here's how you find it if you want to find it yourself. I search for Peg Solitaire JavaScript, and I like this Miso Hana version. It seems like every time I search, I get these in a different order. It's very strange. But anyway, the Miso Hana version, and I might be saying that wrong, and hopefully it doesn't mean anything bad. But anyway, here it is. Okay. At least the game itself is not offensive if somehow that name is. I think it probably isn't, but if it's in a language I don't completely understand, I could very well be saying something horrible, so my apologies. All right. So this here is kind of the standard Peg Solitaire board, and you can find it depicted in the assignment right here in the center, the standard board as I call it. Okay, so how do you play the game? Now, for your assignment, you're not going to be making a playable Peg Solitaire. You're not going to be making a playable Peg Solitaire. You're going to be solving a Peg Solitaire board that's given to you and producing a solution. Does that make sense? So your program is going to play and solve it essentially. All right, so we only have one empty peg in the middle. And you're like, okay, well, if I'm moving pegs, I probably have to move toward that empty space. The only kind of move that you can make in Peg Solitaire, there's only one kind. It's when you have a peg that jumps over a peg right next to it and lands in the space next to that. And it has to jump over a peg that's there and land in a space that's not there. Okay, so every move is a jump. And when you jump over a peg, the peg you jump over is taken away. Right? Does that make sense? Okay. So it's as simple as that. So you can move down. You can move right. You can move left. Okay? Now this peg cannot move up, right? Even though there's a space for it to go, it can only move by jumping over a peg. That's the only allowable move. So because every move involves removing a peg, there's only a limited number of moves that you can make. Right? Because you can only remove so many pegs before you don't have any left to remove. And the object of the game is to get one peg remaining in the center. Exactly one peg, and it must be in the center for it to be considered a solution, okay? And it is possible to do that for this board, but I'm unlikely to actually do it because I'm just kind of moving kind of haphazardly here. And, you know, you can try to move yourself in a way that you don't leave too many clusters. Now, here's the thing for the assignment. You don't need to have any smarts about how to play the game for the assignment, because it turns out that an exhaustive search is able to solve this game in a relatively reasonable amount of time on a modern computer. So you're good to go there. But here you can see that it says end game in this JavaScript implementation, because it realizes I have no remaining moves, but I did not solve it, right? I left myself with these 5 isolated pegs. In fact, there is even a way to set it up where you don't have isolated pegs. Like in the morning, I ended up having 3 pegs along the bottom. But that situation, there's no moves either, because you can't jump anywhere from here. Because the thing is, you can't jump into these areas off the board, right? Maybe it's obvious, but in your JavaScript program, you're going to be presented with a 7x7 Boolean array representing these pegs, right? And if we have a situation that's depicting the starting situation, it's going to have true values where there are pegs and false values where there aren't. That means it'll actually have false values in the corners because there are no pegs there, but you're not allowed to move there either. So your program has to make it so that it won't consider moves into that location, all right? If we go back to the assignment, not this one, as much as I like that assignment. It's got stars, it's got stripes, it's got everything. Okay. Star fields, too. So here we got these 3 different boards. Let's see how the method that you're supposed to write works. Let me zoom in a little bit more. I like it a little bigger, like that. That's pretty good. Okay. So you're going to write a method called solve. Now that might sound familiar because we wrote a method called solve for peg solitaire. It's going to be a little different though. Notice that this method doesn't return a Boolean, it returns a string. That's kind of crazy. Why does it return a string instead of a Boolean? Well, if you remember how Knight's Tour worked, is that we could leave the knight droppings in the board. And the knight droppings in the board gave us the solution. That was kind of cool. Well, guess what? We can't really do that very well here. Because if you look at it, you can move on top of places you've already been. Like here, I'm moving back and forth there, and these pegs are going all over each other, and I'm moving pegs in places where I had pegs earlier, right? So we can't use that strategy we did for Knight's Tour. Instead, what we're going to do is we're going to modify the board as we go, and we're just going to have true-false values in it, which indicate what the board looks like at any given time. But we'll detect when we get to that solved state. And when we get there, we can actually build a solution recursively. And I have a little couple of paragraphs down here where I talk about the technique that you might use to build the solution recursively. If we remind ourselves of how our code worked for Knight's Tour, we can kind of think about how that might work. Let's go into the PM recursive backtracking, Knight's Tour code. And our code is going to be structured similarly if you follow the recommended strategy, right? So actually, all I'm going to grade is a solve method. But you saw how in class, to make our solve work, we created this other method, which for Knight's Tour I called it make move, but here I'm calling it try move. I don't know why. I just felt like giving it a different name. Because the thing is, it's really try to make a move, right? But try to make a move is too many syllables, so I changed my mind. I called it try move. And so just like the Knight's Tour, you're only trying to make one move at a time, right? Now with Knight's Tour, you are moving a knight from a location to a location, and actually, I think we agreed on that you only need to know where you were going. But for this one, we need to know where we're coming from, probably, because for Knight's Tour, there was only one knight we ever had to move. But for this one, there are a lot of, at any given time, a lot of pegs that might possibly be moving, right? Like, if I look back at what I have now, I can move this peg, I can move this peg, I can move this peg, etc., right? So back to this. Our try move is going to say what it's moving, what it's jumping over, and where it's landing. Now, just so you know, you can definitely phrase the try move method in a different way. And I welcome you to do that if you'd like. But this sort of way to phrase it will simplify it as much as possible because it'll know every spot of the board that it's looking at. Okay. Now, notice that one of the things that you might make sure that you do is to not move a peg off the board, right? So for example, you actually only really have to consider where a peg is landing and make sure it's not landing off the board. Because the thing is, since pegs can only move in straight lines, it can't sort of like accidentally like clip a part of the board in the jump portion of the move, the space that it's jumping over, right? And as long as we never move off a board, we'll never have to worry about starting off a board, right? So we'll never get ourselves into a situation where a peg starts off the board. So, so if you set it up right, you only have to worry about making sure that pegs don't land off the board, right? And that every time you make a move, it's going to be a move like this, where we're jumping a peg over a peg and landing at an empty spot. and ending up in a situation that's like that, where the peg we jumped over goes away, right? So I might be kind of talking about this problem in minute detail. But remember, code has to work with minute details. So you might rediscover all this stuff later, but maybe some of what I'm saying will bounce around in your head and reappear at the opportune moment. When you write your code, it's going to have a similar structure to Knight's Tour. Now, we don't have droppings, so that part isn't going to be there. But we're definitely going to make sure our moves are in bounds, and then we'll make a move, and then if our recursive solve is unsuccessful, we're going to undo a move. So that same idea works. But notice, we no longer have a return value that is Boolean. So how's that string value going to work toward this end? Well, if we look carefully at the assignment again, what we actually want to do is return null if a board is not solvable. And so null is going to suffice the way that false did. Because if something's not solvable, we kind of don't care about it, right? But if it is solvable, we want to know what the solution is. So the string that we return is going to have a solution in it. Now, something weird about this is that you don't know if something's a solution until you get to the end. But once you get to the end and you see that all you have is that one peg in the middle and nothing else, that's the solve state, then you can start returning from your recursive calls. And as you do, you can build the solution through those recursive call returns. But actually, you're going to return backwards. So just keep that in mind. Actually, the solver is going to be nice enough to notice if you build a backwards solution. It will say, hey, this looks backwards, okay? So I'm going to try to make my solver as nice as I possibly can. But the thing about any recursive backtracking problem is that it's definitely possible if you have a little bug somewhere in your code. Like, for example, if you didn't spell out your move using the correct coordinates or something, you mix up your x and y coordinates at some point or something like that, that everything will go off the rails. And then it'll be somewhat tedious and difficult to debug. But I am here to help you if you run into a situation like that. Those of you who have ever attended my office hours or sat with me and seen me help debug the code probably can attest the fact that I'm usually able to help you make progress and debug your code, right? I'm pretty good at that. Okay, so hopefully that's enough of an overview of this assignment for you. Are there any questions that anyone can think of offhand? Yes?
So when you jump over a peg, after you jump over one, how many spaces can you continue?
So you always have pattern. These are the only 4 move patterns. So notice that you jump over a peg and then you always land in an immediately adjacent space. Then a subsequent move could move this peg that landed if there was another one of these patterns that applied to that peg, or you could move a different peg, etc. Does that make sense? Does that answer your question or not?
Yes.
Okay, good. Yeah, so these are the 4 move patterns. Pegs cannot fly arbitrarily far or anything like that. Okay, great. Awesome. Any other questions? Okay, good. Okay, so I did want to spend a minute going over the dice roll. Would you like me to do that? Because we spent some time on it yesterday. Or do we just want to jump into working on assignments? Any thoughts there? Raise your hand if you'd like me to go over dice roll. I see kind of half not. We can talk about it later if you'd rather. Would it make more sense to talk about it later? Okay, so maybe we'll talk about it next time. And I can help folks out with their assignment today, okay? Now, just so you know, I did push out the assignment due date because I was requested by a student who mentioned that there was like an important test in the evening tonight, and a lot of my students were in this test, so I decided to do that just this one time. But I won't necessarily make a regular occurrence of pushing out the due date. And you still can always hand in late at just 1 point of penalty per day, but I pushed out that date too. There's only so many times we can do that because I want to make sure we leave time for that project at the end too. Because in quarters past, I've been a little liberal in moving out assignment due dates, and then there's no time for the project at the end. And that's one of our learning outcomes, is that we have a group a team-based project where we do something that a single programmer can't do. So hopefully we'll start talking more about that soon, I think. We'll start talking about how we're going to specify it. And just the specification part is a good chunk of the credit, because if you look at that learning outcome, it involves several things. It's like defining the problem and documenting it and things like that, apart from the implementation. Okay, and yeah, that's just our learning outcome. It's just there, so I want to appeal to it. All right, So I'm going to stop the recording now. I think we've covered enough of this stuff, and so I can go around and help folks out with assignments. And if you just want to get started on assignment 3, that's cool too. And I'll make sure I have a tester program for it very soon. I have one right now, but I want it to have even more help built into it. So I'm going to add a few more things that should hopefully help you out more, right? I'm not here to make it harder. I'm here to make it easier. Awesome. Thanks, folks.